Right, let's go through this question 1. So we have this function given to be fx equal to 1 plus square root x. This one is the rule. Then after that, for x is all real values, of course, x is more equal to 0. This one is your domain of your f. So for the very first part, we are asked to find what is our f inverse and state the domain of f inverse. So very simple. The very first part is let y be equal to 1 plus square root x. Then of course, I make x the subject, y minus 1 equal to square root x, square both sides. So x is equal to y minus 1 bracket square. So I replace the x with f inverse y equal to y minus 1, right, bracket square. So replace the y with x. So this will give you x minus 1 bracket square. So this is the rule of the f inverse x, and we are asked to state the domain of f inverse. This one, we need to draw the two circles. So for example, I draw the two circle, right? So this is your domain of f, will give you the range of f. So the range of f, so of course this part, right, will be the domain of f inverse, then this will be the range of f inverse. Okay, so definitely it means in order to get the domain of f inverse, I can actually just say, oh, the domain of f inverse is equal to the range of f. So how do I actually find the range of f? This one, you need to use your GC, you sketch the graph. So of course, it's roughly sketch. So this part is the y equal to fx, so this y equal to fx graph. So this is 0. Then of course this part is, I think, is 1. So this is the domain from here all the way to infinity. So this is the domain of f. What about the range of f? The range of f is actually from here, the vertical part, right? Of course, inclusive of 1. So vertical part from here to here. So the range of f, as you can see, right, from your GC, is actually just 1 comma infinity, round bracket, non-inclusive of the infinity. So the domain of f inverse is actually equal to 1 comma infinity, round bracket. Okay, so that is for the very first part. Okay, what about the part 2? So we are asked to sketch this and this, right? Then of course, illustrating clearly the relationship between the two graphs and labeling the axo-intercept. Okay, very simple. So for this, I resketch part 2. Okay, so for this, I sketch here y equal to y and x. So I sketch the fx graph first. So this one is solid circle, so I sketch in this manner. So definitely, right, this will be 0 comma 1. Okay, so the relationship between fx and f inverse is just the reflection about your y equal to x graph. So for example, I draw a y equal to x graph. Then of course, how to draw the f inverse? You look at this, right? So this is 0 comma 1. I flip it, become 1 comma 0, meaning that this part will be 1 comma 0. So of course I do this. So they'll intersect about this y equal to x graph. So definitely, if you find the intersection, so how to find the intersection? You can use the GC, right? So straight away you can get the x value to be your 2.62. So at this part, the x coordinate is 2.62, give or take. Yeah, because we will need it for the later part. Okay, so yeah, so that's for part 2. Okay, for part 3, we are asked to show that if ff is equal to x, means then we are needed to show x cubed minus 4x squared plus 4x minus 1 is equal to 0. Okay, so this one also quite simple to show. So for this is part 3. Okay, so fx is equal to 1 plus square root x. Then your fx is equal to, is as good as saying ffx is as good as saying f bracket 1 plus square root x bracket. Then of course you just sub in, you just replace all the x's with 1 plus square root x. So this will give you 1 plus square root 1 plus square root x. So this is the so-called rule of the ff. So they say, oh, this equation, you equate to x. Then we are asked to show the cubic equation. Very simple. So first, 1 plus square root 1 plus square root x is equal to x. So the 1 you move to the right hand side. 1 plus square root x is equal to x minus 1, square both sides. 1 plus square root x is equal to x minus 1 bracket square. Then you move the 1 to the right hand side again. So square root x is equal to x minus 1 bracket square minus 1. So before I do the square again, right, because I want to get rid of the square root as shown here, right, I manipulate this first. So I expand this, so I'll get x squared minus 2x plus 1. So of course, there's another minus 1 here. So the 1 minus 1 is gone already. So what is left is square root x is equal to x squared minus 2x. So square again. So x is equal to x squared minus 2x bracket x squared minus 2x bracket. So you do the rainbow expansion. What you will get is actually this x4 minus 4x cubed plus 4x squared. Okay, so of course you will see the form already, but not exactly the form that they want. So it's very simple. So you just cancel the x. So means okay, here is x, right? So you factorize the x up. Just one x will do. So x cubed minus 4x squared plus 4x bracket. So you can see that I can cancel the x here, cancel the x here. But nevertheless, there's still a 1 here. So means you need to move the 1 to the very right hand side. So this will give you 0 to be x cubed minus 4x squared plus 4x minus 1. So this is the form that they want. So yeah, so that is for the part 3, very first part. Okay. Then the third part, we are asked to find the value. Hence, find the value of x which ff is equal to x. So how do we do? Very simple. Going back to the cubic equation, so we simply just use the GC to find the solution. So there will be roughly 3 solutions. So of course I use my GC. So from from GC, the x value, right, x is equal to 2.621 or 0.382. So of course there's only one intersection. So if you plot the FF graph in your GC, so for example I plot the FF graph, right, so it looks something to be as such. So something a bit flatter. So when you do the intersection, when you find the intersection between the y equal to x graph and the ffx graph, right, so you realize that your x value is actually equal to 2.62. So I can only accept this. So these both 1 and 0.382 I must reject. So reject both of these. Okay. So after I get 2.62, then of course, how do I actually go to the last part? Okay, explain why this value of x, right, actually satisfy the equation to be as such. Fx is equal to f inverse x. So this meaning just means the intersection between your fx graph and your f inverse x, which is what we found just now. So just now we found there's one intersection, right? And I found that the intersection is known to be 2.62. So the x value is 2.62, which is consistent with the FF graph. So to solve this, to explain this, because f, x, and f inverse x, right, intersect about y equal to x graph at x equal to 2.62. So of course with this, right, your ffx intersect the y equal to x graph at 2.62. So of course the solution actually is the same for both of this part. So that's how we actually solve this question.